Hi everyone, and welcome to our webinar this evening. We are delighted to be joined by Andrew McCauley, who will be presenting on the practical applications of dynamometry testing. So the format for tonight will be a short presentation followed by a Q&A. So we do have quite a few pre-submitted questions to get through, so we will try our best to answer those. And for those who have joined live, if you have any questions during the presentation, please submit these through the Q&A tab at the bottom of the screen. We'll also try and get through those as well. So let's get straight into it. I'm going to hand over to Andrew for a quick intro and then onto the presentation.
Thanks, Kate. That's great. Welcome, everybody. This is the time when you can get your cameras out and really selfie yourself up against my social media and say how smug you are on a Tuesday doing some education, or perhaps you're not live and you're watching this back. Make sure you're equally as smug in the picture you're taking. So I want to really simplify dynamometry over the next, say, 15, 20 minutes using the AXID system that I have. But the key thing is to get some confidence around using dynamometry, some case studies, why measurement is important, and when we are looking at it, what we're looking at and so what. So hopefully over the next 20 minutes, we're going to get into that. Classically. Right, so this slide always gets a mention when measuring force, just because it's so horrific, and hopefully remembers that measuring is important. But what you often find is that people are often scared of using the equipment. Usually what I would see is that you get, with some of the fancier kit, like too much information. So you get lots and lots of data, or a lot of data on a screen, and you're kind of basically looking at, what am I going to do with this? How useful is this for diagnosis? How useful for this is for rehab or return to sport? So I'm going to try and really narrow it down, especially for physios who don't necessarily work in elite sport, but this can obviously be used for that as well. And I want to just get into the basics of what are key factors you need, and why this system itself works quite well from a simplification point of view. What's a really interesting paper, if you haven't ever read this one, is just the idea that people can see movement patterns or loading patterns through something like a squat. So telling if somebody is got a strong quad through a squat is actually quite difficult. People can cheat quite well, and this really good paper by Sigurd points that out. So you can actually do a really good squat but not really have a strong quad, for example. So measuring quad extension, particularly in conditions like return from ACL, is really, really important. And it's being done to death, but if you're not measuring the extension torque, especially in ACLs, then you may be putting people at risk, especially when it comes to return to sport. Squats and heavy squats are not enough. And obviously with the leg extension, you're going to be measuring rec fem because it crosses over the hip and the knee. So it's an interesting study if you haven't seen it. A couple of kind of basics again, just we need to look at the force velocity curve when we're looking at measuring force, and the type of force we're going to be looking at with my patient case studies in a little bit. So just to show you the force velocity curve, if you're not familiar with it, I've used kind of athletes in this case, but I'm also going to use the general pop in a second. So we've got that heavy force, heavy lifting, top left-hand corner. Then we've got the middle where there's power. You're moving a reasonably heavy object quite explosively. And then you're moving down into the bottom where we're looking at change of direction, agility, and speed. And if we flip over this, we've obviously got people who are maybe just performing a task like getting out of a chair once. That might be their repetition max, or one repetition max. So we got to bear this in mind. It's not just for athletes when you're looking at the force velocity curve. From a power point of view, I like to use the lawnmower. It's a nice one again for general population when they're having to move a reasonably heavy object at explosive speeds. You can put anything in there, but that's something that we need to get patients back to. And how are we going to measure that? And how can we use the equipment that I'm going to show you for this kind of decision making? And then finally, down the bottom, we've got somebody who might just every once in a while have to sprint or do a quicker jog, especially if he's looking after his grandkids. He's got to run and the grandkids making himself towards the road. You've got a sprint after him. So we've got to bear these in mind. It's not just for athletes when we're talking about measuring force. Again, I'll draw you to this paper, which is a look at older adults and the importance of power training. And so as we just mentioned in the force velocity curve, power there, which is you're moving a reasonably heavy object fast. And in a lot of cases, that can be your own body. And it's the importance of it in the older adult, because I'm sure people are aware, and if they're not, we lose muscle mass every decade from our 30s onwards, up to 10 to 17% actually. And what we lose a lot of is actually recruitment of type 2 fibers. We lose that 2 to 3 times more than strength. So that explosive power that we have, we lose that very quickly and a lot as we get older and per decade. So it's important to know, because if you are dealing with the older adult, are you getting them to do power movements, or, like we're going to get to the case studies, are we assessing power, or in this case, rate of force development, which we're going to get to. Just so, again, making it into some practical application, falls is one of the biggest killers. I've got some data from the WHO. It's the leading cause of death over the age of 65 because of things that happen, obviously, after hospital admission. In the US, which is, couldn't get any UK numbers, but I'm sure there are plenty, 30,000 deaths per year because of falling. And there's a higher mortality in females who fall. So training power and therefore assessing power through dynamometry may be very useful when you're trying to plan rehabilitation. I just want to look at kind of key stages in rehabilitation as well. So these are my key stages in strength rehab, by the way. So this isn't just general rehab. This is when you're trying to improve strength with somebody. So you obviously have to find out what stage of rehab they're in. So obviously there's contraindications to some post-surgical stuff, but you're trying to establish quite quickly to your objective, subjective and objective, where they're at. And this is where a measurement can come in. So sometimes people will guesstimate that they can do running or jumping or any kind of task like that without actually any kind of evidence to be able to see whether they can cope with it. We can obviously use body weight tests like calf raises, single leg sit to stand, but it doesn't actually measure force to the specific muscle. We also got to be looking at rehab goals. So if they have a goal, what is that? And can we build our rehab around that? Now, that could be a target like strength, power, but we need to establish which one it is, which will be something I want to mention when we get to our patient case studies later, and how important it is to distinguish between those two, and then therefore how you're going to target that over the next, say, 6 or 8 weeks with your patients. If they have a performance goal, obviously, if you have a performance goal, that's going to be the main goal, usually returning to some sort of athletic activity, or in some cases, it could be a job performance goal. So that needs to be there as well, because that's going to sit alongside a rehab goal. Patients probably going to be more interested in the performance goal, because it's obviously going to maybe have, say, a financial link to that if it's a job, or obviously an enjoyment thing or a social thing when it comes to sport. The rehab, so we be interested in rehab, they'll probably be interested in performance, and hopefully we can gel that together. But first of all, we need to find out where we're at with regards to measurement. Again, SDA is just a shorthand for sports demand analysis, or you could put job demand analysis. We're looking at what is the capacity required for that person to get back to that thing they wanted, whether that's a performance goal, as we mentioned before. So it's important to break that down. For example, in a tennis player, you'd want to look at how many overhead shots they may take in a game. Now, it could be an estimate, obviously, but you're trying to look at that, because if you're trying to return somebody to sport, you'll want to make sure they have the capacity to do that safely, or that you've tested it in clinic. Again, coming back to how important measurement is, and how do you measure currently? Once I have that measurement, though, as well, especially when it comes to strength, it allows me to implement a specific strength program, whether it's obviously a little bit more sometimes complex than this, and dosage is for another day. I can't go into that right now, but that's something I'd want to take into account when it comes to the patient's pain, etc. But if we're just looking after strength, what I want to do is have some sort of measurement so that I can see progress, or that what I've implemented in that rehab is actually doing something or changing something. Obviously, you want to apply the principle of overload. Obviously, motor recruitment and mechanical tension is going to be important in your rehab, but obviously measurement is going to form the basis of that. Then you can obviously retest, and retesting allows for good feedback to the patient that they're actually achieving something. You're obviously getting the feedback that you're actually changing something, that what you're doing is probably having an effect. We can't lay it down to everything we do as a therapist. Some of the stuff we do might be through natural history, might be the fact that the pain is reduced, but retesting often gives patients, especially with the longer term rehabs, taking longer than 3 or 4 months, that little bit of motivation to see that the hours they're spending on these exercises are actually paying off. And a lot of patients, when they do come and see the data, they get really motivated to go again, often come in a little bit down, see that they're making progress, and it just bumps them on a little bit further. And then you get into the progress bit, and this is where I want to we're going to be highlighting in some of the patient case studies about when to progress, and do we need to change, or do we just need to apply a different type of force, or do we need to speed it up, or where are we at with regards to the stage of rehab or the rehab goal? For example, can we move to somewhere like, do we need to move something like plyometrics, or increasing that power or rate of force development that we might need to do, especially for that task? So you can hopefully see the stages there are quite important, because that will be something you're going to come back to once you've measured again. I think it's important to understand the term impulse. It's once I understood this, it was really, really useful when I'm starting to understand the piece of kit that we're going to use. And when I show you graphs later on around the case studies, you hopefully can see the point of it. So impulse is the functional force, and it's a combination of the rate of force development and peak force. So as you can see on the left-hand side, you've got force, and down the bottom you have seconds. And so 1 second to 5 seconds. So what happens is this person applies a certain amount of force, in this case, very quickly within that 1 second, and then sustains that force for 5 seconds. So everything in that blue zone is the functional force, or the impulse. And this can be positive or negative in impulse. So that means you can either apply force, like for example, a tennis ball against a tennis racket, and you apply short contact time but high force, you can get obviously an increase in force as the ball accelerates away. Or you can obviously absorb that ball into the racket for a kill shot, where the ball spends more time in contact with the racket. And so you're spending time in there, and that's killing the ball's force. So you can be negative and positive. The key thing here is the two variables, which is rate, how fast you produce the force, and the peak force, because this is something I want to show you why it's relevant and how can it be useful for your patients. So let's say patient A comes in, and they well, actually, hang on. Yes, so that was, let's say, this is patient A, so they've come in and they produce this. This is patient B, so they are the blue. So they come in, and you can see from the diagram that they lack a rate of force. So the rate of force is so much less than the first patient, which is the yellow. However, both patients do produce the same amount of peak force. It just takes patient B 5 seconds to get to that force, which you can see on the right-hand side of the diagram. So has got peak force, but lacks that rate of force development. And that's going to be important because you've got a reduced impulse here. And if you only have a dynamometer that measures peak force, then you may be missing out that rate of force, which again is really important when it comes to function. Because if we shorten this right down, and I probably need you to shorten this a little bit more, but that's within 1 second of the force that you're able to produce in these two patients. So the combination of yellow and blue is patient A, and patient B is the blue. And the reason I've narrowed it down to 1 second is because most athletic activity happens in 0.02 to 0.08 seconds. So it's very, very fast, and we want to be able to produce force fast, hence the combination of rate and peak force. So that's why it's really important that impulse is measured and not just peak force. I think it's going to be some of the questions that I often get asked around this is, have we got normative data? The ACSID system actually has a back end to it, which has all the education and the papers around normative data. Now, obviously, in certain populations, it's got to do with athletes or certain genders or certain ages. So you certainly have to kind of make yourself brush yourself up on the particular papers around the particular recommendations. In the quads, however, we do have some evidence that goes across kind of all ages and genders. Now, the fancy equation is 3 newtons per meter per kilogram of body weight, which in general terms, and I like it easy, is around 50% of body weight. And that's across all ages for normal function, which is in some ways quite a lot. But when you think about people who come in maybe in their 60s and 70s and struggle to get up and down stairs, it's often because they just don't have that strength. And as I said to you before, we're losing strength by up to nearly 10 to 15% or 17% per decade. So it's quite significant. In the athletic population, in these papers, it's even higher. And then in certain, depending on who you're speaking to, again, the closer to body weight, the better, especially in the athletic population. What can happen, though, is peak force is important, but as I said to you before, we may need to bear in mind rate of force development because of the impulse factor I've just mentioned. So peak force is great, but again, if you cannot access that quick enough, and particularly, say, for example, the older population, you may have to move quickly to get off the road and get back on, or suddenly stumble and need to get their leg out in front, rate of force is actually quite important. And again, I'll mention that in some of the case studies. So we'll get to our first case study. And this is Alan, and I've actually put a little video on here as well. Is it kind of extra? It's not a little extra for you. It's just to show that the patient's real. And then I'm going to give you some data around him. And this is just something that's quite interesting. He's a total hip replacement, 75-year-old gentleman. You know, he's definitely in the smaller percentage of 75-year-olds who wants to go to a gym and work out and be more athletic. You can see this is the crutch on the right-hand side on the right picture. And this is something I do with hip replacements or post-hip surgery quite a lot. And it's a kettlebell carry, which seems to alter their gait. So we're just going to play the video. Just it's not necessarily to do with dynamometry, but it is important with regards to force and resistance. So if we can see Alan here on the left, he's 3 weeks post hip replacement, and we're going to watch him just walk up and down, and we could kind of have a classic discomfort on that right hip as he walks. And what Alan is actually experiencing during this is some pain as well when he walks. And then when I put a 12 kilograms, so you hear kettlebell in his right hand and make him hold it out to the side, what will happen is you can see that his Trendelenburg, if you want to call it that, or his shift becomes less. And he also reports a lot less pain. So what's quite interesting about something like this is that these patients often get a lot of confidence from this exercise alone, because not only do they walk in with a crutch, and when I hand them a kettlebell that weighs 12 kilos, they're massively surprised that I'm saying this is going to have an effect in a positive way. And when it does, most of this, Alan's already had his kind of light bulb moment, and he was just kind for me to do a video of it. But they often have this big surprise in their face that it actually helps. So it's one that you can apply to rehab. It works. It's never not worked for me. It usually sits around 12 to 16 kilos, male and female, funny enough, not sure why. You can email me your theories and mechanisms. Everyone loves a little theory behind why this works. But it massively affects their gait pattern and often affects pain, which I'm very keen on, especially when we're trying to get that early walking pattern nailed down. But moving on, because I just want to put maybe a little bit of a face to the case study, we're going to get on to Alan's data. Now, this is what you will see. I'm going to give you slightly different slides on each one, and I've highlighted a few things. But you can see in the top left, this is the kind of information you're going to get after you do a leg extension peak force. So again, I'm not going to go into the technicalities of using the kit, but the kit is very easy to use. If you've used Dynamometry before, it's very easy. I just want to kind of go through what the data shows and how important it was for me from changing rehab, for example. So what's quite nice here is you can see down the very bottom of the graph that you've got dates. So you've got the 22nd of September, the 19th of October, and the 2nd of February just gone. And then up in the top left-hand corner, you've got L and R, which is obviously left and right, and you've got kilograms of force. If we go to the first little dot here, so this is what we found on his first test, which was a 14% difference between his left and right. So again, the green being right and the purple being left. So his right quad, there was a 14% deficit. So we wanted to try and see if we can improve that limb symmetry index, which is the difference between the left and the right. What I've highlighted up in the top right-hand corner in the big oval red, it says BW percentage. That's body weight percentage. And what it does is it gives you, because you enter the weight of the patient in, it compares the body weight to force ratio. Now, this percentage is from the 2nd of February, his latest result. And that's up near that 50% mark, which we were looking at for functional force, which is really important in obviously these patients because they want to get back to getting up out of chairs, walking up and down stairs, etc. So it was a really nice progression. So you can see here on the 19th of October, he had a 1% LSI. And then again, in the third one, his LSI increases. So he actually does it better. He has an increase in LSI of 4%. So that means there's a difference of 4%. Anything less than 5% could be totally error on the day. It could be effort. It could be a lot of things. What we see, though, is the trajectory is both are going up. So we're improving force and we're getting close to that body weight 50%. So you can see also, which is quite nice, under the 43.6 kilograms, there's a green arrow saying increased by 26%. And then on the right side, an increase in 20%. So we can see that these are all really useful figures for the patient to see the progression. But if we're looking at peak force here, we're kind of going, well, he's nailing it pretty well. And then if we go to the rate of force development here, we can see the bigger differences. So if we again look at the very beginning when he came in, there was a 56% difference in the rate of force development. So remember I was saying that slant, that upward curve, that ability to produce force fast, which is really important according to some of the research over even normal strength, because they can't access those fast twitch fibers. And then in the second one, you can see there's an improvement. He's dropped to 25%. And then in the 2nd of February, he's got a 2% difference. So we've really improved his rate of force development here in these three dots. And again, if you go up to the major kind of color spectrum there, you can see the green arrows. And on the right-hand side, you've got that 58% increase from the very beginning. So it's a significant improvement in force. Now, why this was all useful is when he came in on the 19th of October, and I could see that rate was a problem over peak force, I started to get him to move the weights faster. And what I just said to him is when he was in the gym doing his leg press, leg extension and leg curl, is that on one day he would reduce his force by about 50%. Now, education around power training is not for today's lecture, but what I did was I just reduced it by 50% and got him to move the weights faster and more explosively with some coaching cues that I use. And that's what he did between the 19th of October and the 2nd of February. He would have one strength day and one power day. And these were the results that came back. So again, really, really impressive results, really useful for him. And it's, again, it implicates the importance of power training and measuring. So come back off that. So this is, you know what, slide, get rid of that. Sorry, guys, 1 second now. So this was, sorry, it's blocking my view of the screen, so I couldn't just get rid of that there. So this is a left superior tib fib dislocation in a 19-year-old rugby player. So it's a really unusual injury, something I've maybe seen once before, but certainly when he said to me, very unusual injury. So when he's come into me and we've done some measurements, so knee extension was the first one we looked at. Obviously, he's obviously dislocated his knee, and you can see again very similar. This time I put three visuals together. So the very top one is just looking at those graphs. So it's very similar to what I did earlier on when I was looking at impulse. You can see these graphs overlapping, and those graphs can be really useful if you're seeing kind of say certain little dips in that, or say slant offs, for example, so where it dies off at the end. In this case, you can get quite solid, solid overlapping graphs here. So that's in the top section. If you move down to peak force, which we saw again with Alan in the previous one, we can see that he's made some good improvement from the 19th of January to the 17th of February with his strength training. So if we're looking at some of the data here, so he's now got a 2% difference. Now he has dropped off on his test by 5% on the right. So in 72.1 kilos, he's dropped off by 5%. But on the left, he's improved by 10%. So overall, his peak force and limb symmetry index is good. If we go to the body weight percentage, if you can remember, he's above body weight, which is 83%. So he's doing really well. He's nearly 83% of his body weight. So peak force wise, he's smashing it. What you can see to the right of that, those who are interested with regards to data or normative data, is they have any of the research AXIT put on, or the Strength by Numbers company put on the references that you need, and then that's available to you whenever you need it. So if you wanted to look at the papers, it gives you the reference of what that normative data is. You just got to be clear about what that population was they studied. So we've got peak force coming back to knee extension, thinking this is pretty good. But if we look down at his rate of force development, it is now dropped. So he's now actually gone, if you can see on the 19th, he's gone from a 3% difference to his 10% difference. Or sorry, a 15%. Yeah, sorry, he's had a drop off in rate of force by 10%. So his left to right comparison is down. So peak force is good, so that's great, but his rate of force is down. So this is something where we might be thinking, actually, we might need to start to introduce power training or more explosiveness, because he's dropping off on his rate of force. His peak force is good, up or above body weight, or above 70% of his body weight, but we may need to go to some power changing treatment or rehab. Now, what's interesting though is when he came back, he was saying that his knee felt better, but when he started to run, he was getting ankle pain. And it was only when he was running. He could jump, he could do lots of other functional activities, but when he ran, he started getting ankle pain. And that's when I looked at dynamometry for his left ankle eversion, because obviously he had a superior tib fib joint dislocation. And then when I looked at his ankle eversion, you can clearly see here the difference in his peak force and rate of force development in his ankle. So this straight away made me think, right, we need to get to some loading of his ankle and guided him towards eversion strength work, including some slow peak force work and also rate of force development. So this allowed me to change my rehab up, because I completely forgot, obviously it's a superior tib fib, got completely lost in the knee, and actually forgot that obviously it's going to have a possible effect down at the ankle, which is what he was complaining of when he started to try and run again. So this allowed me to then focus my rehab towards the ankle and get me good objective measurement. Now, this was an interesting lady. This is a 55-year-old GP who had a diagnosis of a rotator cuff tear. So he'd been seen in London and been seen by a surgeon. But the snag is that she had absolutely no pain and absolutely full range of movement with no functional problems for her. She had some issues around strength and force production, but she had no other symptoms. So the first surgeon she saw had recommended that she gets on and has surgery. And then she came to see me for an opinion. And I said, well, look, when it comes to rehab, well, she was getting she was getting a second opinion from another surgeon who actually had said to her when he did see her that he didn't want to operate because she had full function, and that if he goes in and operates in a 56-year-old non-traumatic cuff tear, he could actually make things worse, and there's a high percentage she'll tear again afterwards. Now, she does have interesting numbers in her data. So peak force for external rotation at 90 degrees was obviously reduced significantly, so 24% and a 34% rate of force. But if you look at her internal rotation, she's got significant reduction, so up than 68%. And the reason why I measured her as well is because she wanted to find out whether rehab was worth doing and what she could do from a rehab perspective moving forward. And what we thought was, if we had some rehab baselines, We could also help out the surgeon as well, because we've got two surgeons, one saying we don't need surgery, the other saying we do. If she does have a subscap tear, there is some obviously risks moving forward with shoulder arthropathies and further instability at the joint. So this is something we have to bear in mind. But again, she did not want to take the risk of surgery for a number of different reasons. So I've taken baseline levels of force, and then I'm going to, which I have done, and now I'm going to set her a rehab plan for approximately 8 weeks and then review the tests. And so we're going to have a little look at if any of this has changed, or has it worsened. And this could be something that we could educate or not educate, or inform the surgeon around, especially moving forward, if it's something that we need to address early, or can we keep going with rehab. So this is kind of one that it's a really tricky rotator cuff decision. We've got two surgeons split, and I'm going to look at rehab to see if I can improve it and also track her progress on here. This is a 53-year-old runner who came to see me diagnosed with patellofemoral joint pain in her left knee and a right Achilles tendinopathy. Just to show you some data, if you look at the left-hand side, you can see up at the top, it says squat normal. So on the force plates, you can get people to squat, and you can kind of see if they're shifting their weight left and right. Sometimes it's really nice to show patients who are, and you can clearly see if they're shifting to one, or if there's a really significant difference on one side. And then you can actually use it to coach them to see if they can shift that weight, especially if it's pain-free. So they're doing it without noticing. Pain is obviously quite clearly sometimes why they're not putting weight through it, but it's the ones who are doing it who don't realize. Or if you're going to be doing something like weighted squats and deadlifts, you can also see if they're driving through one leg more than the other, which is quite important, especially from a coaching perspective, especially for those patients who are therapists who deal with CrossFit or any kind of Olympic lifting or weight training. But what was useful about the knee extension on the right here, which is what we did for her patellofemoral, and she was making steady progress with her running, but she was still having some issues. We were covering all aspects of rehab. She was maxed out on what she could do in the week, so she was making progress. She was feeling that her pain was less. But if we can look, actually, sorry, on the right hand side, the peak force was 9%, so under 10% is considered reasonably okay. But if we look at the body weight, it's down as low as 31%. And if you can remember, as I said, up near 50%, and certainly near closer to 60 to 74% of body weight for your athletic population is what's required. So it was useful information for her to kind of get on with strengthening her quads, and actually made us decide that she was going to get a gym membership for about 3 or 4 months to see if we could actually get some load through that. So not only guided our rehab, but it also guided her to say, if I want to continue running, I need to get this sorted. I need to invest in in the gym, and that's what I'm going to do. So it was useful for decision making and for her to see these results, especially moving forward. Again, with rate of force development being kind of low again on the right hand side, this was something we could guide focus towards when it comes to power training in the gym. This was a gentleman, so he's a 33-year-old rugby player, so it's amateur rugby, and he's post-clavicle fracture. And what I want to look at is a few things here. What we can see, you've got external rotation, peak force, and rate of force development. So you can see when he comes in on the 16th of November, he's got a peak force difference of 38%. And then as we go, we finish off a peak force of 3%. So a climb up. Obviously, there's that little drop off, and you can see with errors, or you can see with differences on different days. So sometimes you get this little drop off, but it's such a small drop off on the right side that it's kind of leveling out. So you will get this fluctuation. Depends on time of day, depends on warm up, etc. Especially when you're doing dynamometry testing. But you can see the purple is clearly increased progressively over that time. And there's only a 3% difference now between the two. What's important then is to look at your body weight ratios. And again, in the athletic population, especially, they're looking at 17%, which you can see on the right-hand side, and he's hitting 20%. So peak force-wise, we're getting him up to where we want him to be. But then down, if we look at the rate of force development, you can see the increase he's made from when he came in, which is an 82% increase in that rate of force development. But you can still see that he's got a 28% difference between the two. And so that's something that we need to be very aware of in somebody who's going to go back to contact rugby, because they need to be able to produce that force fast. It's no good having strong arm without being able to apply that force rapidly. And that moves to the next test, which is the athletic shoulder test, which was developed by Ben Ashworth, physiotherapist and he's done England rugby, and he's with Arsenal now, the athletic shoulder physio. And he's developed this really interesting test around 90 degrees, so the Y, T, and I position. And now this is where I use the force plates, and you can also use the push dynamometer that you get with the kit. And what's kind of useful here is, again, you kind of have a little look at the differences in peak force is about 1%. But again, if we look at that, it's pretty okay. He's at a significant increase again in peak force, but when we're looking at rate of force again, it's over that 10% mark. So he's not able to apply that force fast at 90 degrees. And again, the same at 135 degrees and 180 degrees. We're looking at the peak force again, pretty good, quite close. But then when we get down to that rate, that ability to apply force fast, he's again above that 10%. And in fact, in that 180 degree position, it's 28%. So this was really useful for him to see, and also how we could guide his later stage rehab and what we were going to do in the gym. So we would load him more rapidly in these outer range positions and tackling positions. ACL, we're nearly finished, just got a couple left. So at the ACL, this was kind of a different kind of case study where he's come back. He has a bit of a really nasty injury. He had a PLC repair as well. And what he was doing was, he's one of those patients who I kept telling him the importance of the quad and ACL, but it just wasn't quite sinking in, because he doesn't really like doing that type of work. He's an outdoor cameraman for the BBC, so he does a lot of outdoor shoots. That's what he wants to get back to. And what he likes doing is kind of getting tired. So he'd go out for long walks. He would just do steps when he'd see them. And what was happening is, he was doing all this extra stuff, but actually I had to show him that his quadricep hadn't changed in the time that we had given him. When I said to you, look, you need to get in the gym, you need to start doing leg extensions. And it turns out that when he would do them, he wouldn't really push it that far. There was a little bit of fear around it. So we had to kind of do these measurements here to kind of show him that there was absolutely zero change in his percentage. You can see that green line does not go up. In fact, it drops off a little bit potentially, and slightly up a little bit, but very minimal. So he's still 38% difference in peak force, which is huge. And I think when he saw that, he could realize that I was saying, if you're going out and doing all this other stuff, you've got to make quad the king for the next 3 months. We've got to get that quad better, or else it's the catalyst to everything else, the change of direction, the uneven ground, the running, etc. And so this was kind of measuring him to show him that actually we need to stick to what the plan is. You need to push this, otherwise we're going to stay stagnant. And when you see me again in another 6 weeks, we're going to have the same conversation. So this really helped him to visualize the importance of this alongside some coaching with him. And just as a study, this is just me demonstrating some vertical jump stuff you can do on the pad. So O'Malley's study on ACL reconstruction shows that after 9 months, we don't really look at vertical jump. And actually, there's often an LSI of 24% deficit between sides. Really, really important, obviously, in return to sport. It doesn't say that you were going to injure the study, but it does put you at risk if you're obviously applying force fast, which is often the case in return to sport. So those plates are really easy to use. You just pull them out and it gives you some nice data around that. If you're interested in anything from me, I run a 2-day course called Unraveling Strength and Conditioning for Therapists. That's available through my Instagram Linktree. Also, NCORE provide courses for me, and HDPN as well. And that's a 2-day course around coaching and implementing the principles S&C, how you can start to dose people, how you can dose the athletic and non-athletic populations, how you can boost commitment to programs, and the psychology behind habits and how you get patients to stick to their programs. Now, Katie, I'd like to invite any questions.
Yeah, thank you so much, Andrew. Really useful presentation, and yeah, so good to see those case studies as well. So we're going to start by answering some of the pre-submitted questions. Again, if you're on live, please feel free to pop some questions into the Q&A tab. For those who've asked about some costs and product information on the Axit system, we can get in touch directly after the webinar on this. But for the questions for Andrew, we'll keep them practical and clinical to the session. So first question, Andrew, we've had someone ask about, so the simplicity is key for them to use technology in practice. So the question is, what is the key to strength assessment being simple and effective?
What is the key? Sorry, could you just repeat that last bit? What is the key?
So what is the key to strength assessment being simple and effective, would you say?
Yeah, well, that's what I've tried to do. You can get really fancy. And as I said, the first few slides, that there's a lot of fancy kit out there, like Isaac, if you're lucky enough to work with Isaac Kinetic, and then you get a lot of data. And I think it puts patients off, or puts physios off, or therapists who are not used to that or scared of it. And I think what you really, if you're trying to get into dynamometry, sometimes I even advise using something a lot cheaper. I used a crane scale for many years, which is a £50 piece of kit, just to see if I would actually use it, because obviously this kind of kit is not cheap. Obviously I'm biased and I love using it and I couldn't go back. But the simplicity is just, you can set people up really quickly with this kit. It doesn't take long. Once you kind of establish the setup positions, it's really quick. And then you start getting really positive outcomes from the patient's reactions to feedback. And that's the big thing. It's really instant feedback, really simple. You often just need peak force and rate of force. And that, as you can see there, just with those two variables, I'm able to guide rehab. I'm able to guide diagnosis. I'm able to change focus. I'm able to reassure. I'm able to get patients to kind of come out of this kind of protective mode where they need to focus in on the rehab that they really need to get done. So it saves me having to bang my head off a wall. I can actually use the data. So it's simple from that point of view, because you don't need loads of variables to really affect patients.
Yeah. And I guess from a sort of, performing exercises point of view, I guess with people starting out with strength tools, I guess using just key exercises that the people are confident with to begin with. And as you sort of build the confidence of using more tools and a piece of kit, then I guess, you can really expand on sort of very experiment with sort of the exercise you can do with strength testing.
Yeah, and that's the other thing is you can use the kit as like nearly a training tool as well, because you'll see, I didn't put up because it didn't want to make it too long today, but like there's all this the standard setup and how to reduce error, and sometimes you do this and you need to understand, like if you can understand the basics between peak force and rate of force, sometimes I do it and I'm like going, there's an error here, or there's a learning effect, or pain has stopped them, or they didn't put in the full pressure. So you learn an awful lot about the patient. And then, as you say, you can kind of start to just make simple exercises. Like I've used leg extension and leg press a lot, leg curl, for example. And with all of this, you can just simply tweak from developing power or developing maximum force really easily. So you can just straight away go, look, I want you to do this in the gym. And you can often just shift the exercise they're doing into a slightly different dosage to involve a power movement. So it's just about making sure that you get over the fact that you only need a couple of things to get going. Don't try and if you're looking at too much data, it's going to scare you off, I think.
Yeah, great. Okay, so next question. How often do you retest with these types of tools?
Yeah, that's a really good question. It depends on the condition and what I'm trying to get out, or how long they've been going away for. So I'd probably at least 4 weeks, if not maybe 6 weeks with force testing, just for the adaptations to occur. Like, again, you get quoted different timeframes for strength, but sometimes it's done just to kind of give some motivation, especially in that first initial interview, and they're a bit maybe down or finding it hard to keep going to the gym. But I wouldn't do it weekly, not at all, or anything like that. Not from a force, especially if you've set them exercise. They'll only have done maybe 2 or 3 sessions by that time, if they're lucky. So I'd say about a minimum of 4 weeks, and then anything above that, it would depend on what I'm targeting, and also say for the likes of that cameraman who just wasn't doing it, I was like, right, I want to just check that this guy's actually going to do what I've just said. I've educated him. He seems like he gets it. But I'm going to get him back in a month and be like, how are you getting on? Is there been any problems? Like, all my patients can call me and let me know, but sometimes they don't. And I want to just get back in and just making sure we're making progress. With somebody who's all over it, I might leave them longer.
Yeah. Okay, great. And then just on that, then, I had a question about can it be used in preventative care settings? So again, is that something that you would incorporate?
So I use it. So there's kind of like when it comes to preventative, prevention is difficult. What I would do is you've got all like markers, like you can do things like mid thigh pull, which is associated with your max deadlift. It's quite a safe way of looking at how much all over body strength they have. You can be looking at vertical jump. You can look at symmetry stuff. So you can look at in somebody who's trying to say reduce their risk of injury. There's between all the push pull and the force plates, you've got a whole bunch of different tests that you could do to allow you to kind of make a suggestion if there's anything here that they may want to address in their I wouldn't call it rehab if they're not injured, but address in their training, so they could look at that. And I do. Some patients come to see me purely for, look, I want to be able to become a faster runner. I want to be able to become a faster winger in whatever sport, and I'll run them through maybe 4 or 5 athletic tests to see alongside something like a leg extension, for example, because again, we've got good data with regards to the body weight. So I'll run them through 5 or 6 different tests and then see if there's anything that comes up on that to say, well, look, this is something you may want to work on, but I certainly wouldn't sell it as this is going to prevent you from getting injured. What prevents you from getting injured is movement preparation and making sure you're doing the sport that you like, but also gradually building it up and exposing over time.
Yeah, great, perfect, thank you. So I'm just going to address a couple of the questions that's come through the live from Stephanie. Stephanie's just asked about what program do you use? So I'm guessing she's just referring to sort of where the data's coming from, which is obviously the Axis system that we're talking about. Would you say? Yeah.
Yeah, unless she wants to she's put a second question as well. Yeah, I guess if she's asking me what system, it's what Physiquip are providing, which is the strength by numbers AXIT equipment. I guess that's what you're saying. And with that, as you said, the really useful thing about it, it's user friendly. It's very user friendly. You've used different types of dynamometers, and this is the quickest and easiest way I can get to the information I want. That's why I like it. And whereas other systems can sometimes be a bit more too much, where this is like I've just shown you some of those screenshots are just from the data that I get. It's very, very straightforward, nice progressions. You can see it's all very clear. So patients see it and they're that's the acid test, is that patients look at it and go, oh yeah, I don't need to say anything half the time. They can see it. It's quite clear.
Yeah, so the reporting visuals, like I say, that's all like I say from the system that we're talking about as well. So as well, Stephanie just asking about the average or ideal percentage that the client should look to obtain as an outcome rehab. So is that with the data comparison?
It might be, again, if it hopefully gives a thumbs up, Stephanie, if you're still listening, and if this answers your question. So some of the research is in across populations. And that's where some of again, we don't they'll when you get your results, so the screen will pop up and at the bottom it'll give a percentage ratio for the body weight of this person. What it doesn't do is work out what sport they do and what age they are, for example. They're not going to say, oh yes, this is applied to this research. It doesn't link that. I'm sure that will probably come at some stage. So the papers, you have to understand those numbers. In the back end of this system, I watch webinars. The guys put on one-to-one webinars on all the different kit and all the research that's out there. And then you can watch that and then look at the papers that are relevant to your clientele. And sometimes you'll have a recommendation of 20% body weight for hip abduction, but you have a 60-year-old female that's not a netball player who's 25. So you've got to apply that. you don't have to say to her that she needs to get to that level of strength. So you do have to know a little bit of the research behind this. But it's all provided by the systems, which I like. Again, it's like, right, I'll just go and look that up. And the more you see certain conditions, the more you then start to know who that's for and who's not for. It doesn't take long to get a kind of barrage of which stuff goes across all ages and genders and which actually is specific to certain sports.
Yeah, great. Stephanie's said thank you with a thumbs up. So I think you've answered that. Thank you.
Cool.
Okay, so just a couple more questions. We have a question on some certain techniques that you would use for larger, stronger patients.
It doesn't matter. It doesn't matter if they're bigger or larger. So if I'm getting this question right, the system is they're isometric testing. So the only thing would be they may be alluding to say the push dynamometer. So the one thing, so obviously there's a pull, a push, and plates. The plates. If you're doing a mid-thigh pull, you're pulling against something that's not moving anyway, and the plates you're just pushing in. Your feet are just pushing into the plates, so that wouldn't matter how big you are or jumping on them and all that kind of stuff wouldn't matter. The thing that they may be at is the push dynamometer. So if you're using a push, again, obviously, if somebody was very strong and you were using a push with your hand, I don't recommend that anyway. But the beauty about this system again is they have a little cap that goes on it. It'd be quite interesting if people want to look at it. And what you can use is you can apply that to the wall, so you can actually push into the wall. So again, no matter how strong you are, if you're pushing into the wall or the floor, it wouldn't matter. So the system is robust to really be challenged. I've had no issues with, and I get power lifters in here and people who move big weights. So there's no issue with that if I've answered the question right.
Yeah, great. No, that's good to know. And I think that sort of covers sort of the
Oh, right. I think someone's mentioned for quad extension with the push, for example. So I would not use the push for that. So that's something. First of all, I don't use even if I've used other dynamometers, which I use in other areas of work. I work in the NHS as well. So we have push dynamometers there. So I actually bring in a crane scale for that. So here in my private practice, I use the pull. So I chain it to the bed. And so therefore it gives me a weight, because again, they're just pulling against an immovable object. I would not stand in front of anyone. It don't matter who they are, even if they're, super weak, because it'll either slip and it's very inaccurate. Yeah. So unless you're strapping that push dynamometer to them, it's very difficult. You could use it against the wall with the push, but to be honest, because you've got the pull system, I wouldn't even bother with the push for that particular test.
Yeah. Okay, great. Now I think that covers another question, which was sort of on the pre-submitted bits as well, about it being comfortable for varied abilities. I guess I'd say more advanced abilities to sort of less. And a question on the back of that is, do patients enjoy it? What have your feedback been with patients using it?
So yeah, I just wanted to, I'll answer that, the enjoy a bit in a sec. But yeah, so the nice thing about say someone who couldn't get out of a chair or was quite, like again in certain environments, because you've got that the particular design of the push they have, you can use like the chair handle, the wall, so they could do quite a lot of tests or even pushing against the leg. So what I like to use the pull system a little bit more, but again, the push system works for that. So it's very variable. You can use it across all types of populations. Do they enjoy it? Absolutely. People, and there's no messing, is they're absolutely buzzing to get in the door. If they've tested to do the test, which again backs up with some of the research which I put on my course around commitment and feedback and motivation. Loads of people think, oh, do you need this stuff? It's like going, you don't, you could always rehab people. We've rehab people without dynamometers. But this stuff gives that next level. And I think it's the other thing for me in private practice as well. You could just see patients kind of, they're really challenged and motivated to push it, to do the rehab, to come back and show you that kind of external accountability that I've gone away, I've done what you said, I'm a good boy or a girl, and now I'm back doing, I'm going to show you that I did it. So yes, absolutely, they do enjoy it, and especially the number geeks, but even the ones who don't, or parents as well. That's another one. So parents really see that you're doing a thorough job. It also, this is the other kind of external communication you're doing. You're really being thorough, because a lot of stuff that we say to patients may be true, but sometimes patients don't believe it. They need to see the data. They need to, you're like, look, we don't need to do anything here. You don't need a scan. You don't need something. And sometimes they're like, well, I don't care what research says. I want to see,
Yeah.
hard evidence of this. And I think that's where this offers as well, is when you start using dynamometry. I think one of the questions I think you might have sent me through as well is like, how often do I use it? I
Mm.
absolutely like if I forget to charge the system, I have start heart palpitations,
Mhm.
because that's how much I use it and how much it's really valuable at times. Or when I'm stuck with regards to rehab options, or I'm like, why isn't this? It was a bit like that lady with the patellofemoral. I get that a lot where you're like, where am I at with this? Same with shoulders actually a lot, where you're thinking, is this an instability in the shoulder or a rotator cuff tendinopathy? And sometimes they're surprised by their strength on it. And then it guides you towards, maybe this is a stability issue and you may need to focus your rehab there. So it really helps with diagnosis for me, as well. But yes, to answer the question, yeah, patients they do really like it. And they always go, it's clever. You got a
Yeah.
tablet that works with it. It's very slick.
Looks great,
So
doesn't
yeah,
it? Yeah.
it looks great. Yeah, it's really nice kit.
Yeah, nice. Okay. I just wanted to touch on just a couple with regards to sort of using the kit. Have you had any experience of using it or addressing neuromuscular indications with this type of tool?
Yeah. uh, So, for example, I have a neuromuscular. Well, it's not. I guess they're talking about neuro
I think
patients, maybe.
neuro, yeah.
You
Yeah.
think neuro patient? Yeah, yeah, sound.
Yeah.
So I do. Like, obviously, I'm not a neuro physio, but I do have a head injury client, which is he's a young client, so he's got some left-sided, quite significant tone and some some issues around there from an RTA of his about 3 years ago. So we do a lot of. I use that quite a lot, which is he's involved in an insurance claim as well, so it's quite important because I have to report back to them. And that's the other thing which we haven't mentioned is the amount of times I've sent this reports to surgeons. It sends a really nice PDF. I don't know if you've seen it, Katie, but that you get the PDFs, and they get emailed to them, to the patients, so they can bring it to their surgeons as well, or if they're getting second opinions and stuff like that. So it's really nice from that point of view. Um, but sorry, what was the question again? I've lost my mind off that one. I just went off tangent.
You were just talking about the patient that you've been using it for, who's a bit more like
Oh
neuro.
yeah, the neuro. Yeah.
Yeah.
So yeah. So like I again, it's no. I could say it's a bit like the strong ones. Yeah, it's great. I use it with him a lot. I can't see how it would be a problem. Again, I'm not a neurophysio, but it's interesting again just to get some. It's an objective measure of force. So it's no different. I use grip dynamometers with him because again, his ability to improve his grip and showing that what we're doing is actually having an effect. So yeah, same thing really. I'm sure it'd be interesting to see whether the neuro market would like this or whether they would be neurophysios would be interested in this. But I
Yeah.
can't see why not.
Okay, cool, useful to know. And then balance testing. I know that strength band
Yeah.
have quite a few bit of education, well, newer bits of education on sort of using the force plates and bits of stuff for balance. Have you used it yourself at all? Anything like that?
Yeah. Yeah, so yeah, I've seen that actually, and I went to look on because there's some research around it. That was I haven't seen to be perfectly honest now, I haven't seen the research on it, but and it's interesting you just said that because the patient who we've just talked about, I've actually because
Mm.
he's a long-term client, so I was getting him to play around with it. So I think it would be really useful for that side of things. It's a really nice addition. Whether I'm going to use it in ankles, I need to do a bit more reading, but again, it's really nice kind of again visuals, and they can watch it. So again, very simple. They can kind of try and maintain their balance on it as well. So I've played around with it. I can't say I've absolutely nailed it down and I'm using it regularly, but it is something that I think will be really useful, and I think they'll probably because they seem to be updating all the time as well, which is the other thing. Which is the other thing that's nice, has that inbuilt calibration, which I like as well. So I don't have to mess about with that. It all updates, and so I don't have to worry about any of those things, which I've had to do in previous dynamometers where we've had to calibrate and stuff. This is all done for you. So yeah, the balance thing is I'm sure it'll be useful. Whether it will trump, say, the star balance, for example, for reliability and validity around stability, I don't know. Would it pick up on smaller? I think I just need to read the research, but
Yeah.
it's cool that it's there,
Yeah.
it's available.
Yeah, supporting that as well. Okay, great. So I think more or less covered as we've been chatting there on a few of the other questions, obviously about bits of normative data being available and patient retention impacting patients, which absolutely yes. Let's say patients have really engaged with it, whether that's sort of helping with apprehension or motivation for bits of programs.
Yeah.
Lastly, then the last question. We get this quite a lot when we're talking about these bits of systems is time for clinicians within
Yeah.
the clinic, and obviously like how quickly can you perform testing, is
Great.
that
It's a great question, because I'm an absolute, you know, we've got a hard enough job as it is,
yeah.
and this is the thing, you know what I mean, for time, and time's always on my course. People always go on about it, and I love any tech or any piece of kit that makes me that shortens the time to do the assessment. I'm all over it, even if it's a simple app to measure range of movement and quickly does a calculation for me. If that saves me 30 seconds, then I'm more likely to do it as well as a therapist. And so to answer that question, yes, this kit, once you've set up kind of, because the other thing about it is just where you set things. Like the force plates are the force plates, but when it comes to, like, say, maybe the pull dynamometer, you might just need to know what you're going to attach it to and stuff. So once you've established that, which doesn't take very long, then it's really quick, because all you need to do really is you get the app, you open it, you put in very, very basic details. It's like name, date of birth, height, and weight. You do need something to measure that, though, and I would advise getting something like that. That is definitely worth it. So just that for accuracy. So height and weight, and then straight away the system is there, and you can do load, like with any good tech. There's loads of, if you're really into it and you can get really fancy and build programs and stuff. I'm not that. So I'm the perfect candidate for like a monkey, because I'm just like, right, show me something really simple and I can get to it. So I go straight into, and I just pick the test that I need, and then it's bosh straight into it. So it's as quick as you can do. And because it calculates everything, in the past, I'd have to do those calculations. I'd have to compare to body weight. I'd have to get on my phone. It just goes bosh. And because it's all quite nice and pretty, as patients can straight away see it, it's saved on the system. I can send it to my online notes if I want. So it makes it even quicker that way to store.
Yeah. Okay, great. No, that's really good. I think that'll be useful for everyone. So yeah, I think we've covered everything there, Andrew. That's great. And I think we've got through sort of any questions which are coming through the live as well. So thank you for that. So yeah, we've just made it to the hour, so we will close up now. So thank you for everyone who has joined us, and thank you, Andrew, for presenting this evening. We appreciate your time and expertise on this. So following this session, everyone will receive a link to the webinar recording, so you can review anything. And for those, who couldn't make it live, you'll also receive this. If you want to get in touch with us regarding any bits of the questions on the system, then please do. But we will outreach for anyone who were answering any questions. So thanks again for joining us, and I hope you all have a good evening. So yeah, thanks, Andrew.
Thank you. Cheers, guys.
Bye.